Now, in a previous video, I talked about working with Boyle's law, Gay-Lussac's law, and Avagadro's law, and using those to solve for unknown variables. If you're given them, well, really you only need to memorize the ideal gas law. That's the most important equation. But let's say you're given a problem that's Boyle's law or Gay-Lussac's law and Avagadro's law, and asked to solve it as if you're working with those laws, but you really only remember the ideal gas equation. Well, there's two ways of doing this. And basically, in both cases, you're kind of re-deriving what you would have done with these laws, but you're just only having to memorize the ideal gas equation. So the ideal gas law, just a refresher, PV equals nRT. So whereas before with working with those three gas laws, you had to identify what was being changed, what was being held constant in order to figure out which of the three laws you're working with. In this case, one approach is just to basically take the variables that are changing and isolate them to one side of the equation. So let's say you're given a Boyle's law type problem where pressure and volume are changing. Well, these are already on one side of the equation, so we don't have to represent this as nRT anymore. This can just be your constant K1. Let's say you're dealing with something that is like Gay-Lussac's law. You have temperature and volume changing. Well, I can just rearrange this and get V over T equals nR over P, and this just ends up being another constant. Or let's say I'm given Avogadro's law problem where I have volume and moles changing. Well, I get V over N equals RT over P, which is just a constant. So one approach to these types of problems is basically lump the unknown variables to one side of the equation and just represent them as a constant and solve for the constant. So let's say you're given a Boyle's law problem. 2 liters, 101.325 kPa, and you drop the volume to 0.4. Well, in that case, you just solve for P times V, 101.325 times your starting 2 liters to get K1, and you grind through it, solve K1, and then solve for your unknown pressure without other conditions. Or, again, if you're given other types of problems, just work with this. Now, a second option, and probably honestly the most utilitarian approach to take, because you're going to use it every single time anyway, is take a ratio between the ideal gas laws. So if I take the ratio of the ideal gas law at one set of conditions, represented by subscript 1s, and second set of conditions represented by subscript 2, my ideal gas constant is going to cancel out. Now, this is always going to be true, but it's only, what cancels out only depends on what's being held constant. So in the case of Boyle's law, where moles and temperature are being held constant, N1 and N2 are the same, T1 and T2 are the same, so I get P1 over V1 is P2 over V2 equals 1. If I want to go to Gay-Lussac's, where I'm holding moles and pressure constant, P1 and P2 cancel out because they're the same, so I get V1 over V2. N1, N2 are the same, so I get T1 over T2. Or if I want to work with an Avogadro's law problem where I'm keeping pressure and temperature constant, again, P1, P2 are going to disappear, I get V1 over V2. My moles are changing, but my temperatures are not. So I get V1 over V2 equals N1 over N2. So using just the ratio of the ideal gas law at two different conditions and canceling out whatever's being held constant in your given problem, you end up with these relationships that you can use to solve for the unknown variable. And this is the method I would advocate to you if you're given problems like Gay-Lussac's or Boyle's law or Avogadro's law and asked to solve for them. Now, I realize I talked to you in an earlier video about how to work with these laws, but honestly, they were used to derive the ideal gas law, and it's the most useful equation you can find out there. It does everything. But if you're not given sufficient information to solve the ideal gas law, so you're not given things like temperatures and moles, you're being told they're constant but not what they are, this is probably the easiest approach to doing it without having to go back and relearn the three old laws. So here's an approach for you, and hopefully you find use for it.